Hey guys, welcome back. This unit has been all about motion, and today we are tying it all together by taking a look at something called motion graphs. So basically what we're going to do is be able to look at a graph and interpret what's happening to the motion of an object based on the slope of these graphs. So without further ado, let's go ahead and jump right into it. So the first types of graphs that we're going to be looking at is distance time graphs. Okay, so a distance time graph basically just tracks the distance that an object is traveling over a period of time. Okay, so our y-axis right here, which is our dependent variable, is going to be our distance, and our x-axis, which is our independent variable, is going to be our time. So we're just looking to see how far something is traveling over a specific amount of time. Now, the slope of distance time graphs tells you the velocity of the object, okay? So basically, if you're looking at a distance time graph, when we're taking a look at a graph, you want to first look and see what's being plotted. So if you see distance on the y-axis, it's a distance time graph. The slope of the graph is going to tell us the velocity. And we need to know with these that the steeper the slope, the faster the velocity. So if we take a look here, we have these three lines. So we have these three objects moving. Perhaps they're racing each other, they're cars on a racetrack. The line that has the steeper slope is going to have a greater speed. It's going to have a greater velocity. Okay, so the steeper the slope, the greater the speed. Okay, so the one in blue, the one in blue is moving the fastest, and then the one in red is moving the slowest. Okay. So what happens if an object is at rest, right? So you're reading a problem, it tells you that an object slows down and stops moving, right? Well, on a distance time graph, we would see this as a horizontal line, okay? Because remember, the slope is going to be the velocity. If an object stops, that means it has a velocity of 0 because it is at rest. So the line will be horizontal because a horizontal line on a graph is going to indicate a 0 slope, right? So 0 slope equals 0 velocity, means that the object is at rest. So if we take a look at a blue line, you can see that the object is not increasing in distance, right? Because the y-axis is the distance. So this means that the object isn't going anywhere. So that means over time it stopped moving. So this object would have been moving, would have come to a stop, and at this point when you see the horizontal line, it has stopped moving. Okay, so it is at rest. Same thing for the red line. The object stopped, it's just at a lesser distance. Okay, so maybe if these are just in increments of 1, 2, 3, 4. So this blue line, this object would have stopped at a distance of 4 meters, while on the red line, this object would have stopped at a distance of about 2 meters. Okay, so again, this is distance versus time. This shows us that these objects were moving and then eventually stopped. So the distance or the position will stay the same. Okay, so this lets us know on a distance time graph, if you see a horizontal line, that object is at rest. Okay. If we see an object with a constant velocity, then that just means that it's going to have the same slope. Okay, so if the slope stays constant, that means it's at a constant speed. But remember, velocity also has a direction associated with it, okay? So if you see an increasing line, the object, let's just say, is moving forward. Here, the object would stop. And then if you see a decreasing or a negative slope, that's just going to be an indication that the object is going back to the starting point, okay? So it has a constant speed in the opposite direction. Because again, velocity is that vector quantity, it has a distance or a direction associated with it, a direction associated with it. So what this interpretation of this graph would mean is that the object was increasing, or the object maintained a velocity in the forward direction, it came to a stop, and then it maintained a constant velocity and went back into the opposite direction. Okay, so again, with distance and velocity, you have a direction associated with it, okay? So the slope is always going to be the velocity, and a constant slope with a straight line just means a constant velocity. So the object had a constant velocity in the forward direction here, and a constant velocity in the reverse direction here. Okay. And then last for the distance time graph is to be able to tell when an object is accelerating. Okay. So changing velocity or acceleration will equal a changing slope. So constant velocity is just going to be a line with a straight line. Okay, so what we saw in that last graph. So it has the straight line associated with it as a constant velocity. Here we have these curved lines indicating that the acceleration is changing. Okay, the velocity is changing, which also means a change in the acceleration. So if you have a line that is curved upwards, that would show that the object is increasing speed and has a positive acceleration. If you see a line like this that's starting to curve in this direction, this would be a decreasing speed and a negative acceleration, aka a deceleration. Okay, so if you see a curved line on a distance versus time graph, that's going to be our indication that the object is either accelerating if it's curved in this upward direction, or decelerating if it's curved in this kind of downward direction. All right, so those were distance time graphs. So we were looking at the distance an object was moving over time. Now we're going to look at velocity time graphs. So in here, our velocity is going to be graphed on our y-axis, so it's going to be our dependent variable, and our time will still be our x-axis, so our independent variable. Okay, so the velocity will be dependent on the time at which the object is moving. Okay. In this case, the slope is going to be the acceleration of the object, and a steeper slope is going to be a faster acceleration. Okay, so the slope for velocity time graphs are acceleration. So taking a look, if we have an object of rest on a velocity time graph, this is going to be our indication that this object is not moving, okay, because it has a 0 speed. Remember, on our distance time graph, we also saw a horizontal line on our graph when an object was at rest. However, because we were graphing distance, this line could have been up further, okay? So in this case, it's got to be at 0 and it's got to be a horizontal line. So on a velocity time graph, if you see a horizontal line at 0, that means the object is at rest, okay? If an object has a constant velocity on a velocity time graph, it will also be a horizontal line. However, that line will be at the position of the constant velocity. So in this case, this particular object would have a constant velocity of 4 meters per second. Okay, because it's right above here, I would say this is right at 4. So we would say this object has a constant velocity at 4 meters per second. Okay, so there's no acceleration or deceleration here because the slope would be 0, right? So it's at a constant velocity. So for a velocity versus time graph, if the object is at rest, it's at 0. And then if it's got a constant velocity, there's going to be a horizontal line at whatever position the value of the velocity is. So if we have an accelerating object, we're going to see a line with a positive slope, okay? Because remember, the slope of the line is the acceleration. So a positive slope equals an increasing acceleration, which is positive. And remember, if an object is accelerating, it is moving faster. So the speed is increasing, and the acceleration, because the slope is positive, that's a positive acceleration, and then the object is increasing its speed. And then, of course, on the opposite side of that, if we have a graph with a negative slope, so this negative line, this is going to indicate that our object is decelerating. All right, this is speed versus time. So it just shows us that because the slope of the line is negative, that's a deceleration. So the speed of the object is slowing down. Okay, so it's slowing down over time. And that's the end of the graphs we have to know. It can be a little bit tricky, but when you guys go to analyze these, what you need to first look for is number one, am I dealing with a distance versus time or a velocity versus time graph? And number two, you need to know the main key points. We need to know what the slope means for each, and then what a positive slope, negative slope, or horizontal slope means for each. We'll definitely do some practice with these. You'll have a few problems on your test, but if you want some clarification and extra practice with me, of course, let me know or come to my office hours. But that is it for today, and you guys can go ahead and move on to your independent assignment.